Hello, in this lecture we will find the radius of the small circle. In the drawing we have two circles with an internal lunge between them at this point. Let's call the internal lunge between the two circles point N. Point N is the touching point between the two circles, and we know that this angle is a right angle, this angle is a right angle. AC equals to 9 units, BD or DB equals to 4 units, and we want to find out the radius of the small circle. Let's define the center of the small circle as point Q, and we will define the center of the big circle as point P, and we also have in the drawing three tangents to the small circle. This line segment is tangent to the circle, to the small circle at point, we will call this point S. S is the touching point between the tangent to the circle, Okay, the line segment, this line segment is tangent to the circle at point S, and the line segment CD is tangent to the circle at point, we'll call that point M, and this line segment is tangent to the circle at point, we will call that point L. So this line segment is tangent to the circle at point L. Then we will draw radiuses of the small circle. First of all, we will draw the first radius to point S. So we have a radius to its tangent. So the radius is perpendicular to its tangent, because here we have a tangent to the point and we draw a radius to the tangent, and we have a rule that a radius is perpendicular to its tangent. So this angle is 90 degrees and also this angle is 90 degrees. We will also draw the second radius to the touching point between the circle and the tangent to the circle at point N. So actually we have a radius that is ends at point N. So we know, according to the rule, that the radius is perpendicular to its tangent. This angle is 90 degrees and this angle is also 90 degrees. Actually, line segment CD is tangent to the circle at point N, and the radius is actually drawn in this way that its ends at point N, so the radius is perpendicular to its tangent CD. Therefore, those two angles are right angles, and at the end we will also draw a radius of the small circle that ends at point L. So according to the rule that the radius is perpendicular to its tangent, this angle is 90 degrees, and also this angle is 90 degrees, because we have this line segment that is tangent to the circle at point L, and the radius also is perpendicular to its tangent. So this angle is 90 degrees, and this angle is also 90 degrees. Okay, because of the fact that this angle is 90 degrees, this angle is also 90 degrees. And we have here a square QLDN is a square with three angles that are equal to 90 degrees. Therefore, the fourth angle must equal to 90 degrees, according to the rule that the sum of the angles in a square are equal to 360 degrees. So if we have three angles in a square that are equal to 90 degrees, then the fourth angle of the square must be equal also to 90 degrees. And according to the same rule, we have this angle 90 degrees. According to the same rule, in the square SQNC, we have three angles that are right angles. Therefore, the fourth angle of this square must be equal to 90 degrees also. So we have here two rectangles. QLDN is a rectangle because any square that has three right angles is a rectangle, and also shape SQNC is a rectangle because it has three angles that are right angles. Therefore, it is a rectangle. And we know that the opposite sides in any rectangle are equal to each other. So if QL is the radius of the circle, then ND equals to QL, that is also equal to R, because QL equals to ND and QL equals to R. So ND also equals to the radius of the small circle. And according to the same rule, in any rectangle, the opposite sides are equal to each other. So SQ equal to R. Therefore, NC that is opposite to SQ also will be equal to R. Okay? And if we define Pn as X, then CP will be equal to R minus X. Okay, CP equals to R minus X. As you see, we define the radius of the small circle as small r. R is the radius of the small circle, and we will define capital R as the radius of the big circle. Okay? Okay? So small r is the radius of the small circle, and capital R is the radius of the big circle, and again point Q is the center of the small circle. Okay, point Q is the center of the small circle, while point P is the center of the big circle. Point P is the center of the big circle. Again, point Q is the center of the small circle, and point P is the center of the big circle. Okay? In the next step, we will find the radius, we will calculate the radius of the big circle capital R in two ways. We will calculate the radius of the big circle from the right side, and we will also calculate the radius of the big circle from the left side of the circle. So we will start to calculate the radius of the big circle capital R from the right side of the circle. First of all, the center of the big circle is at point P, so AP is the radius of the big circle. AP is the radius of the big circle, and the radius of the big circle equals to AC, that is 9 units, plus CP, and we have already found out that the value of CP is R minus X. Okay, so we found out the first equation is that we calculated the radius of the big circle from the right side of the circle, and the radius of the big circle equals to 9 plus small r minus x. In the next step, we will create equation number 2, that is actually the calculation of the radius of the big circle from the left side of the circle. Okay, actually we calculate the size of PB, that is the radius of the big circle. We will calculate the size of PB, that is the radius of the big circle, that is to say capital R, will be equal to BD, that is 4 units, plus ND, that equals to small r, plus Pn, that equals to x. So in total, capital R equals to BD, that is 4 units, plus ND, that equals to small r, plus Pn, that equals to x. Okay, so the radius of the big circle, capital R, when we calculated it from the left side of the circle, equals to 4 plus small r plus x. Okay, so we calculated the radius of the big circle in two different ways. So because it is the radius that has been calculated, the same radius that has been calculated in two different ways, we can say that equation number 1 equals to equation number 2, because both of them are the calculations of the radius of the big circle. So we can compare equation number 1 to equation number 2, and in this way we will create equation number 3. Okay? So equation number 3 is actually the comparison between equation number 2 to equation number 1. They are actually equal to each other because both of them are the radius of the big circle. So we can write down that R equals to R. Equation number 3 states that R equals to R. Here we'll substitute R by equation number 1, and we will substitute R, this R, by equation number 2. Okay, and we will get that R from equation number 1 is 9 plus small r minus x equals to R from equation number 2 is 4 plus small r plus x. Okay, so equation number 1 states that R equals to R. We calculated R in two different ways, and then we compared between the two calculations. So R equals to R. Here we have R in this side of the equation, and we have R in the other side of the equation, so we can cancel R. And what left after we cancelled R is nine minus x equals to 4 plus x. Okay, 9 minus x equals to 4 plus x. Here we will subtract 4 from equation number 3, and we will get that five equals 5 minus x equals to x. We got that 5 minus x equals to x. We will add x for to equation number 3, and we will get that 5 minus x plus x equals to 5 equals to x plus x is 2x. So we have 5 equals to 2x. We divide this equality by 2 in order to get the value of x. We will get that the value of x, 5 over 2 is 2.5. So x equals to 2.5 units. So we found out that the value of x is 2.5 units. That is to say, Pn that equals to x equals to 2.5 units. Okay, so we have equation number 1 that states, according to equation number 1, capital R equals to 9 plus R minus X. That is actually equation number 1, the calculation of the radius of the big circle. Okay, but we have already found out, according to equation number 3, that X equals to 2.5 units. So we can substitute X in equation number 1 by 2.5 units, and we will get that R equals to 9 plus small r minus X. Instead of X, we will write down 2.5 because X equals to 2.5 units. So we got that R equals to 9 plus small r minus 2.5. 9 minus 2.5 equals to 6.5. So I write it down that capital R equals to 6.5 plus small r. Okay, we got equation number 1 that states that capital R, the radius of the big circle, equals to 6.5 units plus small r. Okay, in the next step, we will state a rule, and then we will implement the rule in our drawing. We actually have rule number 1 that states, according to rule number 1, if two circles have internal lunge between them, if two circles have internal lunge between them, then the distance between their centers is equal to the difference between the lengths of their radiuses. Okay, so I will read rule number 1 again. According to rule number 1, if two circles have internal lunge between them, then the distance between their centers is equal to the difference between the lengths of their radiuses. And again, we can implement rule number 1 in our drawing, because actually we have here two circles that have internal lunge between them. The two circles have internal lunge between them at point N. They are touching each other at point N, so they have internal lunge between them. Therefore, according to rule number 1, the distance between their centers, the center of the small circle is at point Q, and the center of the big circle is at point P. So the distance between the two circles, the centers of these two circles is actually PQ. So actually rule number 1 states that the distance between the centers of the two circles, that is to say PQ, equals to the difference between the length of their radiuses, is equal to the difference of the lengths of their radiuses. The length of the radius of the big circle is capital R, and the length of the radius of the small circle is small r. So according to rule number 1, PQ equals to capital R minus small r, because of the fact that the distance between the centers of the two circles, that is to say PQ, this distance is equal to the difference between the lengths of the radiuses of the two circles. That is to say, PQ equals to capital R minus small r. Okay? So here we can add small r to equation number 4, and we will get that capital R equals to PQ plus small r. Okay, we got that according to rule number 1, equation number 4 states that capital R, or the radius of the big circle, equals to PQ, that is the distance between the centers of the two circles, plus the size of the radius of the small circle. Okay, but we have already found out, according to equation number 1, that capital R equals to 6.5 plus small r. That is according to equation number 1. Okay? According to equation number 1, capital R equals to 6.5 plus small r. So we actually can compare equation number 1 to equation number 4. We can say that R equals to R, and that will be equation number 5, that states that R equals to R, R equals to R. So according to equation number 5, PQ plus small r equals to 6.5 plus small r. Okay, according to equation number 5 that states that r equals to r, PQ plus small r equals to 6.5 plus small r. So we have r on both sides of the equation, so we can cancel r, and we will get that the value of PQ equals to 6.5 units. So, okay, PQ equals to 6.5 units. Okay. That is actually the distance between the centers of the two circles. Okay, so we have here the value of PQ, so we actually will add together by a straight line points P and Q. We'll add together points P and Q by we'll draw a straight line between points P and Q, and actually triangle Q and P, triangle Q and P is a right triangle because this angle is a right angle, is a right triangle, and therefore we can implement the law, the Pythagorean theorem in the right triangle P and Q, or Q and P. Okay, so according to the Pythagorean theorem, the square of the hypotenuse of triangle P and Q equals to the sum of the squares of the perpendiculars. That is to say, PQ square, PQ is the hypotenuse, PQ square equals to PN square plus QN square. So, according to the Pythagorean theorem, in the right triangle P and Q, PQ square equals to PN square plus QN square. But we have already found out that PQ equals to 6.5 units, and we found out that Pn that equals to X equals to 2.5 units. Or we can write down that 6.5 units squared equals to X squared plus Qn. Qn is the radius of the circle, yes? Qn is the radius of the circle. I wrote here, Qn is the radius of the circle. So we got the equality that states that 6.5 square equals to X square plus R square. And we have already found out that X equals to 2.5. Okay, so I write it down. We got that 6.5 square equals to 2.5 square plus r squared. Okay, we substituted x by 2.5 because x equals to 2.5, and we got that 6.5 square equals to 2.5 square plus r square. 6.5 square is 42.25, and 2.5 is 6.25. Okay, so I write it down. 42.25 equals to 6.25 plus r square. Okay, we got that 42.25 plus equals to 6.25 plus r square. Here we will subtract 6.25 from this equality, and we will get that r square equals to 36. We subtracted 6.25 from this equality. Actually, 42.25 minus 6.25 is 36. So we got that r square equals to 36. Here we will take a root out of this equality. The root of 36 is 6. So we got that the radius of the small circle equals to 6 units. Okay, so the answer to the question is that the radius of the small circle, this small circle, equals to 6 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of the small circle. Okay, and we actually know, it is given us in the question, that AC equals to 9 units, DB equals to 4 units, this is a right angle, and this is also a right angle. Okay, first of all, we defined small r as the radius of the small circle, and capital R as the radius of the big circle. Then we defined the center of the small circle as point Q, and we defined the center of the big circle as point P. And then we actually have something else. In this small circle we have 3 tangents to the small circle. This line segment is tangent to the circle at point S. This line segment CD is tangent to the circle at point N, and this line segment is tangent to the circle at point N. Okay, actually we draw a radius of this circle to point S, and we know that the radius is perpendicular to its tangent, so this angle is 90 degrees. Then we draw a radius of the circle at point N, at the point that line segment CD is tangent to the circle, and again the radius is perpendicular to its tangent. For that reason, this angle is a right angle, and this angle is also a right angle. Then we draw a third radius to point L, to the point that this line segment is tangent to the circle, and again the radius is perpendicular to its tangent, so for that reason this angle is 90 degrees and this angle is also 90 degrees. Okay, so here we have in the square QL and D, we have three angles that are right angles. This is a right angle, this is a right angle, and this is also a right angle. And we know that the sum of the angles in any square is equal to 360 degrees. So if we have already three angles that are right angles, the fourth angle in the square QL and Q must be equal also to 90 degrees. Because if you have in any square three angles that are right angles, then the fourth angle must be equal also to 90 degrees, because the sum of the angles in any square are equal to 360 degrees. And the same thing is in the shapes SQCN. We have in this square, in this shape, we have three angles. It is square with three angles that equals to 90 degrees. This angle is a right angle, this angle is a right angle, and this angle is a right angle. So, because of the fact that we have in this square three angles that are right angles, the fourth angle must be also a right angle, because the sum of the angles in any square is 360 degrees, and we have already 270 degrees, so the fourth angle must be equal to 90 degrees. So we actually proved that we have here two rectangles. SQCN is a rectangle, therefore side SQ that is parallel to side CN are equal to each other, and if SQ is the radius of the small circle, then CN is also the radius of the small circle, and the same thing is about the square QL DN that is actually a rectangle. And in this rectangle, we know that the opposite sides are equal to each other. So if QL is the radius of the circle, then ND is also the radius of the small circle. Okay, so we actually proved that CN is the equals to small r, and also ND equals to small r. And we defined Pn as x. So actually Cp will be equal to Cn minus Pn. Again, Cp equals to Cp equals to Cn minus Pn. That is to say, Cp equals to Cn, that is r, minus Pn, that is x. Okay, so Cp equals to r minus x. Okay, and then we actually calculated the radius of the big circle in two different ways. In the first way, we calculated the radius of the big circle, that is to say capital R, from the right side of the circle, and we found out that the radius of the big circle equals to AC, that is 9 units, plus CP, and we have already found out that CP equals to R minus X. So the radius of the circle, as we calculated it in the left side of the in the right side of the circle, equals to 9 plus R minus X. Then we calculated the radius of the big circle from the left side of the circle, and the radius of the big circle from the left side of the circle equals to BD plus ND plus Pn. again, the radius of the big circle as we calculated it in the left side of the circle equals to BD plus ND plus PN. That is to say, the radius of the big circle is BD, that is 4 units, plus ND, that is small r, plus Pn, that is x. So in total we got in equation number 2 that the radius of the big circle equals to 4 plus small r plus x. Okay, so we have two different ways we calculated the radius of the big circle. So we can write down that r equals to r, because it is the calculation of the radius of the big circle in two different ways. So equation number 1 is r and equation number 2 is r. So we can create equation number 3 that states that r equals to r. Then we substituted r in equation number 3 by equation number 1, and we substituted r in equation number 3 on this side of the equation by equation number 2. And we got that r, that is 9 plus r minus x, equals to r, that is 4 plus r plus x. And we solved this further equation and we found out that the value of x is 2.5 units. Okay, the value of x, that is actually Pn, equals to 2.5 units. Okay, then we actually have equation number 1 that states that r equals to 9 plus r minus x. R equals to 9 plus r minus x, according to equation number 1. But we have already found out that x equals to 2.5, so we can substitute x in equation number 1 by 2.5 units. We substitute x by 2.5 in equation number 1, and we found that the value of capital R, that is the radius of the big circle, equals to 6.5 plus small r. Okay, that is what we have found from equation number 1, that capital R equals to 6.5 plus small r. Then we presented rule number 1 and we implemented rule number 1 in our drawing. According to rule number 1, if two circles have internal length between them, then the distance between their centers is equal to the difference between the lengths of their radiuses. Okay, so if we have two circles with internal length between them, then the distance between their centers is equal to the difference between the lengths of their radiuses. Okay, so we actually can implement rule number 1 in our drawing, because in our drawing we have two circles with internal length between them at point N. They are touching each other at point N. Therefore, according to rule number 1, the distance between their centers, the center of the small circle is at point Q and the center of the big circle is at point P, the distance between their centers is actually PQ. And this distance is equal to the difference between the lengths of their radiuses. That is to say, PQ equals to capital R minus small r, according to rule number 1. Okay, so we have equation number 4 that states that PQ equals to capital R minus small r from one side, and we have from the other side equation number 1 that states that capital R equals to 6.5 plus small r. So we can compare capital R from equation number 4 to capital R from equation number 1 and states that capital R equals to R. Okay, so we can compare equation number 1 to equation number 4, and so equation number 1 states that 6.5 plus small r equals to equation number 4 that states that capital R equals to PQ plus R. So PQ plus R, that is capital R, equals to 6.5 plus small r, that is also capital R. Capital R equals to capital R. Here we have small r in this side of the equation, and we have small r in the other side of the equation, so we can cancel r, and after we canceled r, we found out that PQ equals to 6.5 units. Okay, we found out the value of PQ, and we actually know, then we connected together points P and Q by a straight line, and we actually have a right triangle. PQN is a right triangle, and we know that PQ, we have already found out that PQ equals to 6.5 units, and PN, that is X, it equals to 2.5 units. And Qn is the only missing variable in the triangle QPN. We have the hypotenuse that equals to 6.5 units, and we have Pn that is 2.5 units, and the only missing thing is Qn, that is the radius of the small circle. So we can solve this according to the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, PQ square equals to PN square plus QN square. Okay, according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. PQ square equals to PN square plus QN square. We know that PQ equals to 6.5 units. PN equals to X. And QN is the radius of the small circle that we want to find out. So 6.5 units equals to X, that equals to 2.5 units plus R squared. 6.5 squared is 42.25 units, and 2.5 squared is 6.25 units. Okay, and then we subtracted 6.25 from this equality, and we got that R squared equals to 36. Then we took a root out of this equality, and we got that R equals to 6 units. So the radius of the small circle equals to 6 units. Okay, the answer to the question is that the radius of the small circle equals to 6 units. Okay, thank you very much.